Okay, let's move on to something new, a tangent graph. To start graphing tangent, we are going to recall our unit circle and remember that our tangent was always our y-coordinate over our x-coordinate. So if I'm at 0, my coordinate point is 1, 0. And if I do my y divided by x, 0 divided by 1, I'm going to get 0. We're going to skip to pi over 4, radical 2 over 2, radical 2 over 2. Y divided by x is going to be 1. That's for pi over 4. Let's go to pi over 2. This is going to be 0, 1. So y divided by x is going to be undefined. And we're going to see what that looks like on the graph in a minute. So this one's pi over 2. Then let's go to 3 pi over 4. That's going to be negative radical 2 over 2, comma, radical 2 over 2. Y divided by x, it's going to be negative 1. And if I make it all the way around to pi, I'm going to have negative 1, 0. Y divided by x is going to be 0. 5 pi over 4. Now I've got negative radical 2 over 2 and negative radical 2 over 2. So divide those and get a positive 1. At 3 pi over 2, we are at 0, negative 1. Y divided by x is going to be undefined. Okay, anytime you see that undefined, you're looking at an asymptote. Okay, so let's draw some axes on this graph. I'm going to center it up as much as I can here. Here's my x-axis, my y-axis. Okay, I had a point at 0, 0. Oh, and we're going to say these are all counted by pies, so quarter pies. Quarter pies are usually a good measure to go through on tangent, and you're going to see why in a minute. Okay, so I have a point at 0, 0. I have a point at pi over 4, 1. And I have an asymptote at pi over 2. For asymptotes, I'm going to do this diagonal dashed line. That looks more like an asymptote and not a line that defines an inequality where you did the shading on one side or the other. It looks different. Okay, 3 pi over 4, we're at negative 1. Pi, we're at 0. 5 pi over 4, we're at 1. And 3 pi over 2, we have hit another asymptote. All right. So I can probably continue this graph on the other side of the y-axis, and it's going to keep repeating. When you connect these dots, they shoot off to positive and negative infinity. They're guided by the asymptotes. So this is a little different than sine and cosine in that the period for a tangent graph, how long does it take for it to repeat? It only takes pi to repeat. Okay, if we look at cotangent, instead of y over x, cotangent theta is x over y. So I'm going to look at the same picture, and to make my table, we started at 0, and at 0 it was 1, 0, but 1 divided by 0 is undefined. Pi over 4, divide those two, I'm still going to get 1. Pi over 2, x divided by y is going to be 0 over 1, 0. 3 pi over 4, still going to be negative 1. Pi, x divided by y, negative 1 divided by 0, undefined. 5 pi over 4. Negative radical 2 over 2 divided by negative radical 2 over 2 is 1. And then 3 pi over 2, we've got 0 divided by negative 1 is going to give me 0. So, same thing, let's draw some axes. We're going to put 4 for a pi, or label the tick marks in quarter pies. And start plotting our points. At 0 was undefined, so we're going to put in an asymptote. At pi over 4, we were at 1. Half pi, 0. 3/4 pi, negative 1. And at pi, I've got another asymptote. And repeat. Connect with extending lines, smooth curves. And you've got the cotangent graph. It's a little bit different. It goes up to down, not down to up. And its asymptotes actually start on 0. It's not centered at 0. And for cotangent, the period is still the same. It still takes pi. Okay, we've got the same parts going on for tangent. The only difference is that period is now pi over b instead of 2 pi over b. But A is still my amplitude, C still moves my left and right, and D still moves me up and down. So over here we have amplitude equals 3, B equals 1/2, so that means period is pi over 1/2, which is 2 pi. When I graph this, I want to start centered, because tangent goes on both sides of the y-axis. I know that tangent crosses at 0, 0. And if my period is 2 pi, that means I need to go pi left and pi right. So I'm going to label these negative pi and pi. It doesn't have to be this big. And then I know those are going to be asymptotes. In between, I've got one period. Tangent goes down to up, so when I'm halfway on this side, I need to be down at negative 3. This comes from the amplitude. And then halfway on the other side, up at 3. And there's my curve. Okay, see if you can't figure this one out on your own before listening to me. My amplitude is 3, but it is flipped over. B is 2, so period is pi over 2. Now if I go to my graph, I'm going to center up x and y axis. Tangent starts at 0, 0. In this case, my period is pi over 2. So I'm going to label this pi over 2, pi over 4, because I only need to go halfway, and pi over 4 over here. That way, in between my two asymptotes, I have a total distance of half pi. Okay, it's flipped over, which means that instead of going down to up, I'm going to go up to down. So halfway, I need to be up at 3. And halfway on the other side, I need to be down at negative 3. Drawing my graph this way, I have room to start another period, so I'm going to. And it would look like this. Okay, let's graph a cotangent. Same story. A is 1/2, so my up and down is going to be 1/2. B is 1/2, which means P is pi divided by 1/2, which is going to be 2 pi. and I need to move everything up 1. So let's center up axes. Cotangent, my asymptote is on 0. Since I'm not moving left and right, I'm going to go ahead and put it on 0. Period is pi. So between here and the next asymptote, I need to go 2 pi. Period is 2 pi. So let's count this as half pi's. So this is going to be pi. My next asymptote is going to be over here on 2 pi. And if I go backwards, there's negative pi. Here's my next asymptote. Okay, cotangent, I'm going to go up 1 instead of being on the x-axis. Cotangent goes up to down, meaning it goes like this. So that over here in the middle, I need to be up a half of a unit. That's where my a come into play. And on the other side, I need to be down half a unit. Okay, repeat on the other side, since there's room. There you go. Let's graph another cotangent. A equals 1/4, so I'm squishing my curves in. B equals 1, so my period is going to be pi. C is negative pi. Remember, it's the opposite of what's in there, so that means I'm going left pi. I need to take that into consideration when I mark my x-axis. Okay, tangent or cotangent, normally the asymptote would be on 0. But since we got to move it left pi, I'm going to go ahead and move my asymptote left pi. I'm going to label these in quarters, so there's pi over 2 and pi. So instead of being on 0, I'm going to push it over left to pi. Period is pi, so in between my asymptotes I need to have a full distance of pi. So I end up still with an asymptote on 0. And again at pi. Okay, cotangent goes up to down. So up, that's just 1/4. If you label these in ones, I guess we could count by halves and make it bigger, but we'll leave it here. Wait, that's not right. If that's ones, that's labeling these in quarters, so I was doing what I was thinking. Okay, so here's a 1 period of cotangent and 2 periods of cotangent. Try this one out so you know if you're ready for tomorrow. Amplitude is 3, B is 4, so P is pi over 4. Okay, x and y axis. Didn't move left or right, so my asymptote is still on the y axis. I've got to go 1/4 pi before I get to my other asymptote, so I'm going to space those out appropriately. I'm going to cross in the middle since I'm not going up or down. Cotangent goes up to down, so I make sure I'm up at 3, down at -3. And there you go.